Okay, we're looking at doing probabilities, but we're doing probabilities now with two-way tables, not just with set notation here. Again, don't forget that idea of probabilities. Probability is what we're interested in, divided by the total. That'll help you as well. There are a couple of other simple ideas. There's a couple just terms here. Guys, we're always going to have, and this is why we're using two-way tables. We're always going to have mutually exclusive events or overlapping events. Mutually exclusive events are events that do not occur at the same time or do not happen at the same time. So that would be mutually exclusive, and then overlapping, they do happen at the same time. Let me give you an example of this. If we were rolling a six-sided die, and I said, like, let's say event A is getting an even number and event B is getting an odd number from that six-sided die, those are mutually exclusive because they won't happen at the same time. Okay? So let's say I say event A is getting a 2 and event B is getting an even number. Well, that can happen at the same time because 2 is an even number. So. All right, so that's what we're looking at with mutually exclusive and overlapping. They happen all the time in two-way tables. This is a two-way table. You guys have probably seen this before, but we're going to have these numbers that are put in there. Anything that has a value in here has an overlapping event, and then anything that would be a 0 would be something that would be a mutually exclusive event in this. Most of our two-way tables are going to have some sort of value that goes into them, okay? All right, so we want to fill in our two-way table first. So if I look at this information, I've got 80 children that went on the trip. That would be my overall total right here. And then they went to London or York. We've got 23 boys and 19 girls that went to London. So 23 boys that went to London. That would be this one because those are overlapping event, 23 boys that went to London, and then 19 girls that went to London, again, overlapping. And then we have 14 boys that went to York. So that would be 14 boys right here. This spot would be an overlapping that went to York at that point in time. And then from there, I can just fill in all the rest of it. Obviously, this number is just going to be 23 plus 14 right here. Okay, I can go down this way as well, and I can just add 23 and I can add 19 together. That would give me 42. And then I can find these totals because this 42 plus this number should give me 80. So if I just subtract 42 from 80, that will give me my value there, which would be 38 here. And then I can find this number because 37 should be added to this next number to give me 80, which should be 43. And then once I've got that, I can find this number right here because 19 plus this number should give me 43. So if I just minus 19 from 43, it'll give me that. So that'll give me 24. So this would be my two-way table. I do not have any mutually exclusive events with this two-way table. Well, I shouldn't say that. Don't just say that for that. So our mutually exclusive events would be like those that went to London and York. Nobody went to both those places. They just went to one or the other. They can't happen at the same time. Okay. So that would be a mutually exclusive. So this is my two-way table. Once I've got my two-way table, I can answer a bunch of different probability questions. Like for example, I could ask you if I chose one of the 80 students, what's the probability? What would be the probability of me selecting somebody that went to York if I just randomly selected? So that would just be the total people that went to York that I'm interested in again over the total, which should be just 80 there. So so we can ask a bunch of different questions that way. Okay, let's look at another one here. So this one we got to finish the table here first. This is a table set of students and the year that they are in school, classified by boy, girl. Okay, and so what I'm going to do is look at this one. I'm going to find the other values here. I'm going to find this one by subtracting. So going 256 minus 123. That gives me the 133 here. I'm also going to find this number by subtracting these two numbers from the 831. So 831 minus 256 and then minus the 303. That gives me 272. I can find this one by subtracting the 125 from that one. That would give me 147. Then I'm going to find this value by going 407 minus 133 and then minus 125. That gives me 149. And then I'm going to go 303 and then minus that 149 from that, which will give me 154. And then I can find this number by going 831 and minus 407 as well, which will give me 424 there. Okay. All right. So from here I can answer a bunch of different questions. These are intersections questions. These are kind of nice that way. So if I looked at this one, let's do this first one. What's the probability of selecting a boy and a ninth grader and a boy? So this would be that intersection question. I need them to be both characteristics, boy and ninth graders. That would be this 149. That's what I'm interested in, over my total, which would be 831. So interested over total, and that would be my value. 10th and girl, so 10th and girl would be this 123. That's how many meet that I'm interested in, and then the total would still be 831 with this one. This one, that's a 11th and a 10th grader. Well, guys, there's no overlap with that. So there are 0 that meet that category, and then still out of 831, or 0% chance of that occurring. This next one would be 11th and girl. 11th and girl would be this 147 out of 831. So that's how you do and questions. If I do or questions, like let's say the probability of selecting a boy, or let's say a 10th grader. So if it's one or the other, then I take the two totals. So the total boys would be 407, and I'm going to add that to the total 10th graders, which would be 256. But I have to be careful because actually I've counted this 133 twice, so I have to minus the 133 out, and then that'll be all over 831. And that would give me my total value there. When I do all that, I would get 530, and that's all going to be over 831 is what I'd get. And that would be the same as if I did like the union with this. So and or questions, if it's an or question, you got to look at it like this right here. If I did one more of those, like let's say the probability of selecting a girl, and let's say or an 11th grader. So if that was the case, I'd find the total girls, so 424, and then I would add the total 11th graders, 272, and then I'd minus that overlap out of 147 and then divide that by 831. So you have 424 plus 272 and then minus the 147 out, and that would give me 549 over 831, and that would be my or. Again, I could use this union mark instead of the or as well. So, all right, this has been your Math Moment with Mummy. We'll see you.